I'm Nirmal Joy. I'm the Water Resilience Officer with MidCoast Council. Can I go with Catherine, Graham, and John, please?
Yep. Hi, I'm Catherine. I work with Reflections Holiday Parks, and I am in the Capital Works department. So work, along across the whole of New South Wales, I guess, with all of our parks, but particularly with the MidCoast Council parks.
I'm John. I'm the manager here at Ocean Shores Holiday Park at Manning Point.
Ty Donaldson, Park Manager at Jimmy's Beach and Hawks Nest, part of the Reflections group.
Hi, I'm Evan Hunter, Manager of Sandbar and Bushlands Caravan Park and Golf Course.
Hi, I'm Andrew, Manager of the Twin Dolphins Holiday Park, Tuncurry.
Hi, I'm Murray Lanesbury, Manager of Smugglers Cove Holiday Village in Foster.
Hi everyone, Tracy Hamer, Manager of Water Planning and Assets at MidCoast Council.
Yep, Graham Stubbs, Tuncurry Lakes Resort, General Manager, and I've been here around about 10 years.
Thanks, Graham. Over to you, Professor Stephen.
No worries, thank you, Noel. So talking about rainwater harvesting, and I'm going to talk about different systems within the MidCoast Council catchment. Because there's many different water users in the catchment, as you all know, and I'm just, I'm assuming that a lot of you are going to know a lot of what I'll be talking about today. But the idea here is to look at okay, so look, what we wanted to sort of really talk about, or start talking about as an introduction, water demand is the key variable for optimising a rainwater harvesting system. And you're all familiar with what the rainwater harvesting system is. It's a rooftop, it's a hard impervious surface that can direct water to a tank, with varying volume, could be a small dam or whatever. There's lots of examples which we'll talk about a little bit later on. You'll soon learn that I'm a very, very big fan of water metering. Over the last 20 odd years of looking at water demand and looking at the detail and what the actual water demand patterns mean to a rainwater harvesting system have been quite compelling, and I'll be talking a bit about that today. The water metering itself plays a major role in water supply management, and from a MidCoast Council point of view, it gives you a lot of information about lot scale leaks, water supply system leaks, system operation, and with more data that you have from your water users within the catchment, it allows you to sit there and put in a serious plan of what are our water supply needs for the future. Like yourselves, who wouldn't be the largest water users in the catchment, but you do have this seasonal distribution of people coming and going. You have a range of different water uses on site, ranging from pools, amenity blocks, cabins, outdoor water use, and so on. To be able to have point of use should be the cornerstone component of any catchment water supply system. And of course, as I mentioned before, the rainwater harvesting, which up in your neck of the woods are reasonably good. And there is this really tight connection between water demand, roof area, and tank volume, which I really want to go into as part of this discussion. Of what we typically know as a catchment supply water system. You usually have a big centralised storage at the head of a catchment. You have all these pipes feeding all this water to treatment plants and off to domestic users and others. The red circle down the bottom could conceptually describe what a caravan park is in terms of the context of that catchment system. On the right-hand side, we have from the MidCoast Water, Our Future, just to give you a brief conceptual schematic there of what's actually involved in taking water from one place to another, the costs that's relied on. And the one key attribute of all this, rainwater harvesting is never included in this centralised philosophy. It has been over the last 20 years, which is great, but we're now at a point where every user has an opportunity to sort of increase their mains water dependency and in terms of caravan parks. How is water availability? In the next slide, I'll flesh out a bit more. Demand distribution, already mentioned, there's an outdoor-indoor component, which hydrate, toilet, laundry, hot water, etc., dishwashers and the like. And there's a pattern to that, and that pattern and how it's used during every day and during a different year actually has quite an impact on the system modelling itself. Diurnal and seasonal water use patterns, well, again, they're quite important. I'll show you a couple of those later on. I'll talk about rainwater tank configuration and what a typical tank looks like and what it means with a trickle top-up from the mains water supply or one that stands alone. We'll also talk about the rainwater tank dynamics. And by rainwater tank dynamics, I'm really looking at, as a system perspective, that to get the biggest rainwater yield out of any storage, effectively have to maximise the drawdown. And by maximising the drawdown, you have to have an inherent knowledge of what's coming out of the tank each day. So again, I'll be trying to join up these dots as we go. I use a couple of fancy models. The ones I use for rainwater harvesting are continuous simulation based. And by that, we mean at least 50 to 100 years at 6-minute time steps. And we capture the actual rainwater tank level itself. And previous studies we've done, we've used various, or this model in particular, we've had water level gauges within rainwater tanks, and we found that very, very high correlation, which means that we're getting a better understanding of that water demand that is so important to modelling or to actually forecasting our needs for a catchment. Of course, all of you have these wonderful caravan parks, which I've had the pleasure of going to most of them before, and everyone's different. They're all, they're of different ages. They have different components, different site requirements. Some of them have a proportion of campgrounds, powered, unpowered, some fancy cabins, some not so fancy cabins, amenity blocks, swimming pools, and all these sorts of things. And to have an understanding of that sort of site survey, we'll talk about, again, that's very important information when you're looking at a given site. I'm up there talking about water availability, and I love putting up this slide because it tells a lot about how we manage water in Australia. We've got all our capital cities there. The blues, the mains water demand, the greens, the stormwater runoff, and the browns, the wastewater discharge. Now, this is, from a 3-person household on an urban block. But the idea here is if you look at it as a breakdown of all these little lots and what they're actually contributing to your stormwater system, your sewage system and all the like, it's actually quite fascinating. So if you take the green and the brown and put them on top of each other, in most places, we have got more than enough water to do with what we need to do, but we pick them in this water trinity of the supply, wastewater and runoff. But it's always amazing to me that, look, we have got the water, and the reason why rainwater harvesting is such a valuable component is because it can be installed anywhere within a catchment. You can't build a dam anywhere. You can't build a wastewater treatment plant for recycling anywhere. These places have to be quite, configured by the powers that be and the people who are the experts. I'll talk about household scale indoor water uses, and again, I'd like you to just keep in mind that I will be using household water use component data, because when we upscale that to the different uses within each caravan park, it becomes quite important. So this is a typical breakdown of indoor water use. You can see most of it's hot water. Toilet obviously is a large chunk of there. And to me, in a caravan park setting, they would probably be the two that would comprise a large portion of that pie graph in an amenity block, a large amenity block, which, by the way, should have a lovely big roof area on it, which will be beneficial down the track. And when I conceptualise caravan park scale water uses, and keep in mind, I've seen some water use data from caravan parks, but not a lot. Just to sort of take a little side here, my first experience with working with MidCoast Water back in the day was with Graham Watkins when we were looking at all the smart metering around Tea Gardens and Hawk's Nest. There were hundreds and hundreds of homes, and it was fascinating data to look at. You could pick up a holiday home that the outdoor irrigation system had blown up and was, effectively leaking 18,000 litres a day. Just great insights into how the system works and how we can optimise the operation of these systems. So tell me how wrong I am or if I'm close to the mark on this, but I look at a caravan park and I think, well, there's a lot of outdoor space, a lot of landscaping. Whenever I'm there always seems to be a bit of action going on in that space. Accommodations, well, they're not, unless you've got the big 4-bedroom ones, the little cabins with the, 2 bedrooms and this sort of thing, have one bed, one shower, one toilet, quarter of the caravan park, and a mini box where, I suppose a lot of people coming up in their vans and whatever, camping. And again, this is some of the insight into, hopefully, as we keep this discussion moving forward, of the sorts of things that we want to flesh out and then apply to what infrastructure and assets are available on site, and then take another level look and see, well, what is actually required to implement a greater mains water reduction from all of these systems. Diurnal water use patterns. The more data you get, the more fascinating these become. Now, this is a residential household pattern based, I believe, in Melbourne. We had just over 400 homes in Brunswick where we had smart metering. And this is more or less the average of what it looked like. And if you go through the day, start at the 0, that's midnight. That may be some leaks, but it's, just minimal water usage. By the time you hit 4 a.m. in the morning, everyone's getting up in Melbourne, freezing bloody cold in winter. Hopefully not getting on the bike to ride to work like I had to do. But what you'll see is this 3-hour period there where there's a very, very high peak in a morning peak. Now, if I was a catchment water planner and designing a new headwork supply, and by headworks I mean putting in a new dam or whatever large big ticket infrastructure to do this, I would be looking at is that morning peak, because that sort of relates back to the capacity of what my system needs to look at. So the more data you have on flows, on water supply areas and all this sort of things, gives you a much better understanding of how you can act to reduce mains water use at the household scale and above. So if we move through the day, there's a little mid-morning rush, maybe everyone heading off to coffee. Irrigation around midday. Doesn't seem, but again, we had a lot of data. Outdoor use, this is people watering their gardens and what have you. And then this evening peak, which sort of starts around 5 p.m. and goes all the way up to 11 p.m, which is just probably a residual of more people using water at the time for smaller amounts, flushing toilets, taps, doing the washing up, things like that. But they're all very important, and I'll be fascinated to see what a caravan park diurnal water use pattern looks like. And they'll be different from winter, they'll be different to summer, they'll be different with the amount of people that you've got there. So occupancy is going to be another vital factor of when we're looking at water, but all that's related directly to water demand, which we can pick up through the smart meter. So this is how, since 2004, we've in New South Wales, we have the basics regulations as part of the DA for building a residential dwelling. And one of the big things that you can do, which will tick the box straight away, is putting in a 5,000 litre rainwater tank. Now, this is typically for a, something on a 800 square metre lot and below, roof area between 150 and 250 square metres, with an average water demand of say 220 kilolitres per year for that household. And those numbers are all averaged and these sorts of things. So the more data we know about water demand, you can see how we can start to refine and optimise all of our water systems in Australia, which will be very, very important down the track. So here's our tank. We have a minimal water level. We have an anaerobic zone down the bottom. We have our pump, which sends it off for all our water uses. And typically these days, I'm not sure how it is up there with MidCoast Water at the moment, but we connect the mains water to the actual rainwater tank with a little float system. And what that means is And look, we'll touch on this a bit later too, but there's a whole heap of regulations and things you can and can't do when it comes to plumbing a rainwater tank into a house, particularly if you want it to be part of the greater water supply system. So we're at this point where it's instead of having a pump and a rainwater tank standing alone, supplying your house, which, by the way, many people in the MidCoast Council area will have, particularly up in the hills and where they don't have the mains water supply. They'll just have the pump, they'll plumb it straight into the house and use it for whatever. In the urban space, the tank, and instead of, obviously the roof is connected to the tank to deliver the water to it, but the mains water system is plumbed into the rainwater tank itself. So when the rainwater tank runs down to a minimum level, it'll start trickle top up to a point which will effectively satisfy the following day's morning peak. And it allows a greater time, well, gives you greater headspace in the rainwater tank for the probability of rain. So maximising the tank is a very good thing because it means you've got a maximum amount of volume in the tank ready for the next rain event. And to get that right, you obviously have to know how much water is coming out of the tank, which is your water demand. And to know how much water is going into the tank is probably going to be more a function of roof area, which we'll talk about in a minute. Tank dynamics. Now, this was part of a study up in Brisbane a fair while ago now. So we're looking at the month of July in 2008. This is a 5,000 litre water tank. It's plumbed into the house. It didn't have a mains water trickle top up at the time. And it was very interesting because in Brisbane at this time, if you had a mains water trickle top up rainwater tank, it actually fell under the water restrictions. So if it was plumbed into the system, you suddenly have to become part of the system. If there's water restrictions, your tank is part of that water supply. And so there was a lot of toing and froing up in Brisbane, and I'm not sure where it sits now, but it's a sort of discussion that we probably will have to have in the mid-coast area at some stage down the track. So you can see here, we top graph, the red is the rainfall. Well, it's in millimetres per 6 minutes. So, you know, when you're getting 4 millimetres, so these events range anywhere from, say, 15 millimetres up to about 45 millimetres. The roof area on this house was close to 400 square metres. So there was a lot of space and you didn't get that much rain to keep filling up the tank. And so while this is just a small snapshot of a given year, 1 month in a given year, conceptualise the benefits of harvesting this water at the point of use and using it, meaning that you're not relying on the mains water supply. And then having every water user in the catchment having a similar contribution to saving water allows the catchment to, population growth and these sorts of things, allows you to actually plan for much better for the future with better water security. Okay, models and modelling inputs and outputs. Look, there's lots out there. Recent work I've done on Norfolk Island. CSIRO were over there doing a water resource assessment, and they developed a little app that people could use on their phone, designed specifically for Norfolk Island conditions and weather and tank sizes and these sorts of things. But to me, it's very rudimentary, daily time steps for rainfall and water demand. And I'm not going to bore you all with the debate I've had with water industry people in the past, but daily time steps have never been good because I asked the question, well, if the tank's full of water and you get some rain, do you take the water demand out of the tank first before the rain or vice versa? Because whatever decision you make is going to influence your runoff coefficient. And the only way to understand how all of that fits together just on a simple household lot is continual simulation. So some colleagues of mine developed some models, a couple of decades ago. We've been using those in our research for pretty much all that time. They do get published in papers. They're, a lot of them are quite well recognised. There's a group we worked with called eWater back in the day, and they've got an incredible suite of modelling tools on their website, not specifically for rainwater harvesting, but more catchment size, like source. Music model is the one I use for water quality, and we can talk about that when it was towards the end. One of the things I haven't mentioned yet, that one of the benefits of an optimised rainwater harvesting system is some significant reductions in runoff to reduce nuisance flooding and again take burden off the stormwater system. Simulation and the inputs for these models obviously have to be quite robust. So the rainfall data at 6-minute time steps. There's plenty of weather stations up in the MidCoast Catchment area that have that pluviometer data. The water demand, indoor and outdoor. Again, MidCoast have always been ahead of the pack with the water metering. Again, big fan, and because of that, you're going to be have some very, very good outcomes from anything that we're looking at optimizing any rainwater harvesting anywhere. Roof area obviously is quite important because you can have a 400 square metre roof, but if your tank's not in the right place or it's not configured right, you might only have half of that actually connected to the tank. Tank configuration, obviously in terms of volume, whether it's connected to the mains water system, and of course water demand driving that drawdown is something that comes out of this. And what drives that is the diurnal water use pattern within the model as well. So we can put in several water use patterns depending on the time of year. And the outputs that come out of this model, of course, you get to see your mains water use reductions and a whole heap of stormwater runoff data, your annual recurrence intervals, peak flows from that given allotment that you modelled, the amount of wastewater that can be generated, which allows you to reuse it. You can also put in stormwater reuse and a whole heap of other things. So they're quite insightful when you have the right data in them. And again, the more metered data we have, the better it all will be. And I know a lot of you have smart meters in your caravan parks at the moment, which is terrific. So hopefully we can look at some of that down the track. Again, I've pinched this from our recent Norfolk Island environmental assessment because, and I will use Norfolk Island because guess what? They have no centralised mains water supply at all. It is all rainwater harvesting and groundwater extraction. They have extracted so much groundwater that they've got none left. The climate's changing. They're getting significantly less rainfall than what they had. And in the processes of writing up some of their water standards for their DAs, the question was asked, well, how does all this fit together? And because they don't have any water meter data at all, no one's got a water meter on their house, no one can tell you how much water they got. They've all got, an array of different tank sizes from 10,000 litres up to, 100,000 litres plus. And so to get across what the connection is between tank size, roof area and water demand, if you look at a 100 square metre roof, and the dotted line is just the 220,000 litres per year water demand that they believe that they use, which is more or less a back calculation from the amount of water that rushes into their wastewater treatment plant. So there's a lot of missing data in the Norfolk Island scenario, which fortunately for MidCoast Council, you've got that and more. So if you look at the 100 square metre roof and you look at the water demands, which are in that little table underneath, you can see there's this inflection point around the 130 kilolitre per year, where it gets to a point where it doesn't really matter how big a tank you put in, you're not getting any benefits, and it starts flatlining out. So you can put in, it doesn't matter how big a tank you're going to put in, you're not going to be any different to putting in, a 30,000 litre tank, or in this case, a 45,000 litre tank. And the 45,000 litre tank is pretty much what we discovered as being a sweet spot for Norfolk Island. By the way, they've got lots of big accommodations and things like that. There are some similarities between some of these big accommodations on Norfolk and the caravan parks that we're talking about today. So 150 square metre roof area, you can see that the benefits start increasing for the same water demand, that 220 with the black dotted line. And as you move from graph to graph to graph, you can see you get to a point where, look, it doesn't matter how much roof area you've got, you really then have to go back to looking at tank size. And the tank size is driven by the water demand, and in which case here, you can see that for a range of water demands, there are diminishing benefits for just going too big. So how do we actually optimize these systems? So using the Norfolk Island example, one accommodation, they use close to, well, I think it's like just over 180,000 litres per day. And they've got a 10,000 litre rainwater tank and 45 bedrooms. Now, you don't have to be a water expert to understand that, look. And they've got 1,800 square metres of roof area. So there's ample opportunities for that accommodation to optimise by getting larger tanks in that instance, because they can justify it with the demand that they have. The observations from the previous graph, obviously the smaller roof areas are, are catchment limited. If you don't have the roof area, it doesn't matter what tank you got, because you just haven't got the ability to harvest it. And when I talk about rainwater yield, I'm talking about if you've got a 5,000 litre tank and you let it fill up with water and you don't use that water at all, you've got zero yield. You've just got a 5,000 litres sitting in a tank. And as I said, to increase that rainwater yield and the benefit from it all, you have to keep drawing down that tank. And for a typical urban block around Newcastle, a 5,000 litre rainwater tank will provide a 90,000 litre reduction in mains water demand. But they're important, and if as I said, every lot within the catchment looks at optimising whatever they have, this is where we start making the real leaps forward in water management. Larger roof areas, I said, become water demand limited. So unless you're using more water, it doesn't really matter how big your roof area is, and tank volume will vary depending on the land area and cost. And if you're looking for, firefighting requirements in off-grid areas and these sorts of things, part of VAs in some areas are that you have to have 20,000 litres just sitting there unused in case of firefighting. That's understandable. All of this costs money, and that's another discussion for down the track once we start optimising each site to see what's required. Again, the smart metering, the knowledge on the water demand drives all of this. And once you understand what you're using, you can then look at your roof areas and tank volumes and try and sort it out from there. And again, I'm giving another big tick for water metering. Here's some data. This was some data that John sent me. I only had the monthly data, so I just sort of used some very generic water demand figures. But what we're looking at here, just to demonstrate what I've been talking before, if we work on 28 megalitres per year with a 5,000 square metre roof area, you get that solid green line. So you are achieving just over, a 33% reduction in mains water demand. The basics regulation is sort of looking more around the 40%, and I suspect that's why a lot of it still revolves around household water use rather than water users like yourselves. But if you double that roof area, now 10,000 square metres is a hectare, it's a lot of roof area. It doesn't have to be one big continuous roof. And this is where we talk about, well, what roof areas are available in caravan park and how they can be connected and optimised that way. But you can see straight away that doubling that roof area takes you up to, so you probably only need a tank size of 1,000 kilolitres. That's not super large from some of the tanks that are available out there. But then getting even more and more tank sizes is just not doing yourself any favours at all. So between the 500 and 1,000 kilolitre tank size with an increase in roof area, for a given demand of 28 megalitres per year. And this was run through PERS, so it did have those diurnal patterns and the seasonal sort of changes and everything as well. I just thought it's a good first place to start to demonstrate what can be done there. Yours. And this is another great map that John sent me, which typically how I would do this, I'd come up with my drone and I'd do the drone survey of your property and then do the roof counts, and you would come up with a number. You could probably do this one by hand, to be honest, and I might give that a go down the track. But you can see that there's 34 hectares here. John, you can correct me if I'm wrong, but there's about 160 lots. And the left-hand side, probably using pointer, this up down here. I'm not sure whether that's is that a shed, John, with a roof area?
Yeah, that is a shed.
Beautiful. And of course, you've got some cabins. You've got all these little roof areas along here, which constitute impervious area available. The amenity block here next to the pool. To me, that's almost a no-brainer. Hot water, toilets, showers, that sort of thing. And keep in mind, some of you may already have some big tanks next to your amenity blocks and be doing this already, and that would be absolutely terrific. But the idea, I suppose, is to look at all these different opportunities. One thing I'll throw into the MidCoast Water engineers people now is it would be really good if you could have a tank that could supply several of these cabins at once. But I'm pretty well down here in Newcastle. If I built, 2 houses on 2 separate blocks and supplied them from the one rainwater tank, I'm pretty sure that wouldn't be allowed. But it's just food for thought, because something like that, having a common tank feeding from numerous roof areas, could be, because the other alternative is to put a very small tank on every cabin, which I can tell you is probably not going to be economically viable. Well, it could be down the track if there's council subsidies and a whole heap of other things going on, but we won't go into the detail of that too much now. So there is roof area. You can see the open space. You can see there's roads. So again, the water demand data, the smart metering data, hopefully can give us some idea of, what water we're using for what in each caravan park over time. Stormwater runoff reductions. The Brisbane site, where we're talking about water cells, and water cells are they're actually on New Inventors about 12 or 13 years ago, and they're a big food grade polyethylene bag that you actually build into the footprint of your house. If you look up water cells on the internet, his name's Jeff Ball, and he's located on the Central Coast, and he installs a lot of these in what I call McMansions, you're quite large homes, because they can take a fair bit of water. And we're interested at the impact of, we talk about getting too much storage on site, but it does have a stormwater runoff reduction benefit. You can see here, the green dotted line is undeveloped, and so that's just the lot sitting where it is with trees on it, untouched. As soon as you clear the trees and you have your business as usual, just with a demand management only option, which is your half flush toilets and taps and things like that in a house, that black line. If you put in a 5,000 litre tank, you can see that for the 1 in 20 year annual recurrence interval, you're still generating too much runoff compared to what a natural site would be. So keep in mind, I'm talking about runoff coefficients and stormwater quality and natural, all these sorts of things as well when we're generating this. It's not until you put in a 16,000 litres of storage that you actually start bringing it back under to what the underdeveloped is, which means that you're significantly reducing stormwater runoff for a range of different controls. And by controls, I'm talking typically, if you're looking to manage sediment in a catchment, you're looking at a 1 in 2 year recurrence interval rain event is what you would model that on. If you're looking at street drainage, well, typically it's around a 1 in 20 year event. And again, you will never design street drainage for a 1 in 100 year event because we'll never ever be able to afford it. But then when you look at, say, a 50 year event, we seriously look at flood mitigation, and that's where things like dams and, regenerative farming and a whole heap of other factors come into play depending on where you are in the catchment. Several months ago, I was doing some work with MidCoast Council with Drew Morris, and some of you might know Drew, and what he looks at is some of this, what we're looking at here is a chicken farm. The idea here was that you all have seen what the chicken farms look like, and they're not short of roof area in any way, shape or form. But what their main problem is that all that water from the roof typically rushes off into the range, pushes all the chicken excavation work into the local river, which goes down into the estuary. You get a poor report card, and and something probably has to change. For years, we've been talking about harvesting water off this rooftop just as a water security aspect. At this one farm, the red line is their roof area. You can see that they're generating, we're talking what, 130 litres per second coming off this site. Sorry, it's a lot more than that. If you start putting 170 kilo, and by the way, they did have a 170,000 litre rainwater tank right next door to this rooftop. So it wasn't a big ask for them to connect it, which they did. And it finally got their farm plans in action because they'd put up their water point land hydration work, but they didn't have enough water to feed into the system. So it's amazing what you can do if you just jump outside of the box a bit and look at the benefit that you want to do or want to achieve. And in this case, it was reducing the volume of water coming off the chicken range, going into the creek, which was then going into the larger system. And then it's just a matter of deciding, well, how much water are we going to be using off the top head of the farm? Because most of the chicken farms I go to, they don't just do chickens, they do, stock as well and other activities. And to join them all together by using the assets from one to benefit the other, I thought was quite a good thing to do. So if you actually double the tank size up to 340,000 litres, these are a lot greater benefits. And notice the one key thing there. So we're looking at, these are looking like, well, the water demand per day range between 10,000 litres and 40,000 litres a day. So they can be relatively big users, and 10,000 chickens in a shed apparently use 6,000 litres of water a day. It's a bit of trivia. So again, having the water demand and knowing how it's being used and what it's being used for allows you to really drill into the detail and put in the right infrastructure in place to benefit. Towards the end here, so I thought we'd have just a quick look back at. I know I've bombarded you with a lot of information and probably not much certainty on what are we actually going to do from here, Steve. Well, here's where I'm thinking we can do it. From each of the perspectives of the caravan park, the water demand distribution needs to be evaluated to identify these opportunities. Some will be more obvious than others. Some, to be honest, will probably just be too, they just won't be viable to do it. But if we don't look at them and we don't evaluate them in terms of the context of the system, the water system within the caravan park and the caravan park's position in the larger system again, because this is where we're all leading to. It's all part of the MidCoast Council Water Resilience Plan, is what the driver for this. Any water source depends on reliable and accurate monitoring of water use, which again, big fan of metering. Keep it up. If we can put in more, that would be terrific. We address the relationship between roof area, water demand, and tank size. I mentioned that I'd like to see it seriously considered to join up, have a common tank to supply a number of cabins or accommodations within a caravan park. And I suppose where I'd like to see it go today is we've already got a core team now of caravan park managers and operators. We've got people in council, and we can form this core team that can move the discussion onwards. Whenever there's things to be said or questions to be asked, I mean, I'm always around, Nermal's always around. I think the important thing is to keep that conversation going. So where to from here? Again, we mentioned that core team. From council perspective, again, let's keep rolling out that smart meter work because it's it definitely drives the sort of work I like to do and the detail I like to look at. And of course, after lockdown, it'd be good to come up and visit a few of you and have a chat and maybe do some surveys and look at some of the low-hanging fruit, so to speak. And of course, no one's, you're not all on the starting blocks at once. We are from the paradigm perspective, but some of you are going to have, be further down the track than others, and that's why it's important to keep this sort of core group going and talking about things and talking to each other about what's worked and what didn't work, and hopefully we don't have too many of those if we get the modelling right. Discussion moving. Now, I'm not sure how long that went for, Nermal.
No, that's perfect. So it's time for your questions and yeah. So the floor is open. Any questions?
Any questions?
I'll go.
Thanks, Tracy.
So near the start, you showed us a graph. It basically said that we've got enough water. We're just not capturing it all. So is it really just money? And the impracticality of, I guess, retrofitting some houses with rainwater tanks?
Look, no, what you're saying is right. It's look for all the time I've been in this, there's always look, there is a political side to a lot of this. I'll use Norfolk Island I'll use Sydney Water as an example and Melbourne Water as an example. Melbourne seems to have been moving down the track of wastewater reuse and recycling a lot better than what Sydney has. Now, Sydney at the moment, as we speak, there's something like 1,100 gigalitres of kilolitres or megalitres of water a day being pumped out through the ocean outfalls. Yet at times when their dams run dry, we all say, oh, we've run out of water, but you can't run out of water if you're just wasting and pumping it out somewhere else. Now, it is a money aspect to turn that water back inland or back to a point, but you need storage. And the bigger the city you've got, obviously the bigger the storage you need. But I always argue that if you get the demand calculations right and you know where your water's going, there's no reason why you can't have a circular water economy. It's all being treated separately at the moment. Very rarely do wastewater people talk to the mains water people who talk to the stormwater people. But they all connect in the end, and every single one of them has a budget to do something, and very rarely is it integrated to build something which, and this is the sort of thing that I've pushed for on Norfolk Island. I don't normally disagree with CSIRO. They produced a very good report, but their outcomes, their pre-feasibility options were take more groundwater, which from their own study said is still uncertain. We don't know the recharge rate and the depth you have to get it at. While there was a lot there, they didn't even have the equipment on the island to do it. They brought in a desal plant to build or to resurface the airport at the cost of $45 million for the resurfacing, and left the desal plant there, and that only generates 7 megalitres per year. I mean, when you're using 260 megalitres per year and you're talking emergency situations, which they were in, the system didn't add up. And then when I pointed out that they pump 168 megalitres per year of wastewater out to the ocean, and you're due for a wastewater treatment upgrade, and you've got the Balmoral report fully costed for $18 million, where's the administrator on the island to get him moving this through for you? Because you then increase food security, you then increase your ability to take your tourists, and there's all these things going on, but you can't do it without the water. So I put up this graph just to remind Australians that if you're going to sit there and say, we've run out of water, we've got nothing, we've got to build more desal, we've got to build more dams, but I think we're missing the point. That's the big bucket with the holes in it. And making the bucket bigger doesn't make it any better, it just makes it more expensive. I like to think if you plug the holes and then you want to enlarge the bucket, that's probably a sustainable way to go. I just want to remind people that we're not that short of water, particularly on the east coast of Australia. And we can do it better. And it is about money. Yes, Tracy. Yeah. Sorry, long answer to a good question.
Thanks.
So is anyone on board? Has anyone got rainwater tanks on site at the moment that they use for any significant purpose, or is it just all pumping to the mains?
That's a good one, Professor Steve. I know John has a question, but just before that, maybe just answering Professor Steve's question, it would be good to do a round around where are we standing in this. Like, I know that there are people who have tanks and are keen to do tanks. How about we just do a round with like where do we stand in this? John, maybe we can start with you.
I was just going to say, and if you need to refer back to anything in the presentation, please do, because I can quickly flash back to that. So that'd be good.
Yeah, we here at Ocean Shores, we actually have 4 water tanks alongside our front amenities. So if you're able to go to that overhead shot. Yeah, that one there, if you go to, with your cursor up to the front amenities. Where are you? Keep coming. Yep. Yeah, that one there. If you go a little bit more to the right, you can see some trees. There's actually 4 tanks in there. We utilise some of that with the rainwater harvesting from that roof to run our toilets and urinals in that amenities block now.
And have you got a water meter on that, John?
No, I don't have a water meter on it, no.
Well, there you go, Nermal. There's a good prime candidate for a, again, because this is what you want to do. I mean, there's no reason why you can't monitor these things and then write papers and present them at conferences as part of the caravan, side of things, because it is all vital. And there's places I've been to in, from Alice Springs to up north to WA, and I'll tell you what, every single one of them is different. And they all have opportunities because they all do get rain at some stage of the year, and different occupancy rates at different times of the year.
Yeah, so we're actually looking now into the same scenario to the other amenities block, adding some more tanks down there at some stage in the tree area, in the pool area there, which will allow us to do the same thing. So it's the fruits are there. We just got to work out ways of doing it and make sure we get it right. Yeah,
that's well, as I said, that to me is the low hanging fruit. I mean, the amenity blocks they look like they've got the solar panels on them, so energy wise, you're doing that as well.
That is correct.
Yeah, yep. So look, solar panels don't stop your rainwater harvesting capacity.
No. So we utilised the front amenities block, but when the second one was built many years ago, it was never considered. And yeah, we're looking now to try and benefit from the facilitation of using tanks. Any information that we can gather through you guys and that sort of thing is all a major win.
Yeah, well, as I said, I mean, if we had data for what that block uses, that amenity block uses, and I'm talking, say, this one here.
Yep.
and you've got the pattern, you run the model, and then you say, right, oh, well, John, you need, a 25,000 litre tank here to run the demand of that amenity block. Now, ideally down the track, you want to know the detail of that amenity block, maybe some larger accommodations. I'm not really sure, but the amenity blocks, going back to that pie graph I had before, is the amenity blocks water use, that bigger chunk of the pie?
Oh, it would be for sure. It would be.
Okay.
Without meters on it, I'm only guessing, like in each of those amenities blocks, we would have, 15 showers, and then close to 15 toilets, and, a couple of urinals.
Mm. Look, the old school way of doing that is to say, all right, you've got 15 showers, so many toilets, so many baths, you have so many people, they get used so many times, and then you come up with this guesstimate of a water demand. And then if you use that number to size your rainwater tank, it's no surprise that sometimes things are out. But when you've got that pattern, it doesn't really, as I've always said, it's not really about how many people. If you've got 10 people living in a house which has only got one toilet, your toilet use isn't 10 times what it would normally be, because the person, only one person can go to the toilet at once.
Once,
that makes sense?
Yep.
Unless you get three or four people.
So a question for you: if we were going to meter one or both of these amenities blocks, would we put meters on toilets individually, showers individually, laundries individually, because there's laundries in those as well?
You don't. I would just have the smart meter on coming into the entry point to the amenity block, and with good smart meter data, I can look at it and tell you whether someone flushed the toilet or someone's got the laundry cycle on, or someone's having a shower. So all that's very easy to disaggregate out of a good smart meter data, and that's why.
Yeah, right. Well, see, at the moment we have a smart meter on our mains coming in, but we don't have meters on the amenities.
Yeah, well, again, I mean that is a great thing to have, but because you've got so many different uses, it's hard to break down. It's obviously good for leaks and things like that because they stand out. Things like when someone flushes a toilet, I very much doubt that everybody in every accommodation when full would instantaneously flush their toilet at the same time. So it's all these little blips and bumps and things that you see in the data do give you insight, and we're really that was the stuff we were working with Graham back in the day about fleshing all of that out. And I've got a colleague who he hasn't been doing it for a while because he's into other things, but he was my algorithm man. He'd write little software programs to disaggregate the smart meter data. And look, I think you guys have got a copy of something you did. I'm not sure whether you're using it still, but you probably have to talk to Graham Watkins about that.
Yeah, righto. Be worthwhile.
But it's all good. It's all good. If you've got the smart meter data, we've got so much to work with, John. That's the bottom line.
No, well, we'd certainly investigate that to do it on the amenities to see what we can come up with, because it's something we're trying to control.
Yep. Thanks, John. Speaking of the trend, I know, Andrew, we spoke about the trend that you identified from the smart meter data. Do you want to talk about it and a bit about your aspiration around rainwater harvesting?
Sure. So the trend you're referring to, I assume, is when we had a massive quarterly water bill and we took it on as a project to redo most of our mains in all of our park. That scared the living daylights out of us when we got the bill from MidCoast Water at that point. We identified a lot of leaks using the smart meter, and since then we've been doing it almost daily since then, where we're down to a point where I believe we're pretty good in the scale of things. We're like 2.3 litres a minute constant use. So that means we've got a couple of very, very minor leaks. And as you all understand, in a caravan park, it's hard to get everybody to do all their tap washers and leaking toilets. So at 2.3 litres a minute, we're pretty good. We don't want to sit on that, though. We do want to continue going forward. We're very, very keen for the water tank system. This workshop has actually opened up a lot of, or it's answered a lot of questions to me where I was very single-minded that a water tank, you know, held 5,000 litres and that's all it could hold. And what can I do with 5,000 litres? Well, obviously I can do a lot with 5,000 litres the way it's being talked of now. One of our major usages is cleaning areas, like pool areas of the morning, things like that. Our graph shows us it's our major use of the day when we hose down that area. And we've tried lots of other things. We've tried sweeping, blowing, things like that, but with the bats and the birds and all those, you know, lovely things that leave stuff that visitors don't want to see, there is really only one way to do it, and that is with water. So yeah, we're super keen to get into it. I do have a couple of reservations, and they're going to revolve around planning restrictions and health restrictions, things along those sort of lines. But I'm sure as we've got council on board, it won't be too much of a hurdle to get a clear understanding of what we can and can't do. Ground site will be our biggest issue with us, that we are very poor of free land at our park. So that's something we're going to have to work on, and it may cost a little bit more to put things into action on that. But yeah, that's sort of where we're at with ours, and I'd encourage every park to do the best they can, because you're all looking at the same bills I am. And every year the bills aren't getting any better. Put the bills aside. The drought we just all went through, the bushfires we've just all gone through. What a fantastic thing to have all that stuff, that water available to us to use as we need it.
Exactly.
Yeah, thanks, Andrew. Just I know we have spoken about you know, the reservations from the health side of things. So I'm just putting a little fact sheet. Is it? No, that's not a link. I'll put in the right link there. So basically, I had conversations with people who actually, you know, deal with that. So it's basically in terms of if your water is safe from the health perspective, that's good. So, you know, they don't actually look at where the water is coming from. So if when they test the water, and you definitely go through that process anyway. So I'll put the link there, which talks about what can you do with your in terms of the swimming pool with reference to rainwater, and it very clearly says it has to meet the you know, basically you do the chlorination, and you know, you have the little machine sitting there anyway. So I think that will solve the purpose anyway. Yep. Catherine, I know that you have parks working totally on stormwater and some of it tank water. Would you like to, Catherine, are you there?
Sorry,
All right,
I
come
am
back
here.
to
Yes.
sometime.
No,
Yeah,
I'm here. I'm here.
Yeah.
Can you can hear me? Yeah, so I probably have to triple check with our ops team for a lot of it. I know that Seal Rocks is the example that we're running purely on aquifer water and not on town water. And we have just installed some water tanks there to catch the runoff from one of our guest lounges, and we're using that just for irrigation at this stage. And Ty would know more about how many kind of rainwater tanks we have at Jimmy's and Hawks. I'm not actually entirely across it. I know that, so from our capital works perspective, when we're looking at installing new cabins or guest lounges and things like that, putting in rainwater tanks and solar panels is one of the considerations that we do look at. I think the presentation was excellent in terms of, understanding, I guess, that, as I think John said, about it's a continual use rather than a fixed kind of, volume of water that we're looking at. So we are looking at doing a park development at Jimmy's, which will include a pool and some more cabins. And so maybe having a look at what we could do there to take our exec on the ride, I guess, as to why it's really important. It might cost a little bit upfront, but the benefits that we will get long term well outweigh what we would be spending. So I guess that's my perspective in terms of having to use some of the capital there to be able to install it, how we can bring management along with us.
Thanks, Catherine. Is there anything that you want to add there, Chai? Or?
Yeah, so at the moment at Jimmy's and Hawk's Nest, we don't have any tanks, so there's a huge opportunity for us to look into tanks, and yeah, obviously the benefits have been explained, and we are lucky that we do have a development coming, and hopefully that can provide us, with a bit of infrastructure around that. Also, obviously, with the two parks here, so with Hawk's Nest, there's an opportunity also there to capture some water. We've got a lot of roofs, so it's definitely an area that we can work on to be better in. We do have some thoughts as far as projects in the future at Hawk's Nest as well. So, whether we can incorporate those into those projects, or whether whether we work on getting something a bit quicker, that'll be for someone probably other than myself to decide. But yeah, I agree with Catherine. It was a great way to have a look at the benefits, of tank water. And yeah, we've definitely got the room for improvement in that regard at both of these parks.
Thanks, Ty. I have put the link there, which refers to a fact sheet around swimming pools with reference to rainwater, and also just going back to Andrew's concern around the developmental requirements. Basically, to my understanding, what they look at is, of course, there are, it can't be near a heritage property, you can't, so things like that, and the size of the tank with reference to the safety, and from the health perspective, in terms of this water not mixing with the town water. So you probably may have to do a section 68, which make sure that the plumbing is done properly so that it does not mix. Am I right, Tracy? There is there anything else that you want to add there?
No, that was right.
Yeah. So if there are specific things, we can definitely talk to people who does that. We can link you up with them, and I'm sure that won't be an issue. So yeah, Graham, I know that yours. It's a bit of a different story. It's not a caravan park, but I know that you have a couple of tanks there. Do you want to talk about it? Graham, we can't hear you.
He's muted.
Yeah, I think I can see him trying to unmute, but
How's that?
Yep, working. Let's go.
Okay, yeah, we've got a couple of tanks. I've got a main irrigation system around in a quadrangle area, and we currently feed those tanks from several roofs when it rains. I've got a stable area at the back which is no longer used as stables, but we've got a tank that catches the water off that. That also feeds down to, or can feed down to the tanks which run the irrigation system. We 3 years ago redid our amenities area, and that amenities area got kitted up with a 5,000 litre tank, which feeds into the urinals and the toilets as well, on a continuous flow system based on what rain we've got. But I would be interested, certainly after your visit, to talk about maybe some tanks, and particularly for the pool area, because we could feed that water into the pools, or like the other gentleman spoke about, we do a fair bit of hosing around that area for the wildlife. It seems to like the area so much, so I'd be interested to find out some more information about that. But I was surprised we do probably have a couple more tanks or a couple more feeding systems than some of the other parks. So we can certainly add to it, but by the sounds of it, we're not doing too bad already.
Thanks, Graham. I see in the chat that Evan has to go. Just before you go, do you want to add something to the conversation, Evan?
Oh, no, I'm pretty well right. It's very interesting to listen to it. I don't have any tanks here, but certainly we'll be looking into it. Thanks, everyone. Sorry, but I do have to go.
All right, thanks, Evan. Murray, I know that you have quite a large tank in the park. Do you want to talk about it?
Yeah, hi, my name's Murray, Smugglers Cove. We were lucky enough to acquire a 200,000 litre water tank. It used to be for a firefighting use at another park. So we can, when it rains, catch a lot of water off our main entertainment area. So we have that large supply to use. We do use it for, and it's not linked to town water at all. It's got its own plumbing, so there's no way of the rainwater getting back into town supply. But yeah, we're very interested in putting more tanks around the park, especially around our big amenity areas, and utilising that. We also have at least 7 to 8 spear points around the park, so we never use town water for irrigation. It's always bore water, but the benefits and the positives and the negatives for that as well is that because of the smell of it, it's very very brackish, very rotten egg smell. So of course, when you've got clients, that's the last thing they want to wake up to in the morning or through the course of the day. So yeah, it's one thing we can't do a lot of when there's a lot of people around.
Thank you. Professor Steve, do you want to take it on from there, or any questions from anybody else?
We didn't really talk that much about the health side of the rainwater harvesting. Colleagues of mine have done a lot of work on rainwater quality itself.
Your voice is a bit, yeah, sorry.
That's all right. I think I'm definitely going to have to get myself a new camera thing. Anyway. But look, when we talk about rainwater quality, we have. I mean, I look at it as a natural system, just like anything else. I mean, in a rainwater tank, you do get E. coli. That's our indicator organism because it tells you gastro and these sorts of things. There's been lots of studies by Jane Howarth back in the day. 4,000 young kids under 8. There was no correlation between those that drink mains water or rainwater and the frequency of gastroenteritis and these sorts of things. I've always argued that a mains water system, you don't get cryptosporidia and all these sorts of things in rainwater tanks because they're just not given the opportunity to grow. Biofilms within rainwater tanks themselves have the ability to remove heavy metals. The bacteria that form those competitively exclude any other pathogenic type of critters that get in there. And again, things like Legionella, it only grows in a very narrow temperature band, and that's why it's found in engine motors behind air conditioners and things like that. Golden staph and all these other bugs that sort of take on board have to have a sterile environment to take hold. But a rainwater tank with a healthy microbial diversity in it, with its biofilms, they've been demonstrated to actually have a water improvement quality. But if you test it and it's got 1 E. coli in it, well then, according to our rules, you can't put it in the pool. You can't have these sorts of things. Drinking water itself, of all the grand plan, is probably around 1% if that, of the caravan park's water use. So, you know, whether we put, because look, you can get fancy because it's all about the plumbing. I mean, you can just connect the kitchen taps to the rainwater supply and the toilet and the showers to the rainwater tank. Send it through the hot water system, all these sorts of things. But look, they're not hurdles. They are little discussions and challenges that we'll have to have along the way, because it is all about fit for purpose water. So if you've got a big rainwater tank and you're worried about drinking or doing it for certain things, well, let's just focus on what we know we can use it for. And if it's hosing down pool areas and irrigating trees and these sorts of things, well, there's no requirements for doing any of that. And when we optimize it for that system. So
All right. Any other questions? Any comments?
I'll just make a comment. Many of you might be aware that years ago, MidCoast Water had a smart water rebate program where they would provide cash rebates for things like efficient washing machines. And you could also get rebates for rainwater tanks at the time as well, unless you were building a brand new house and you had to put a rainwater tank in for basics. So it was just for retrofitting existing houses. So unfortunately that smart water rebate program ended a few years ago now. But we're currently reviewing our integrated water cycle management strategy. That it's quite a long process and it won't be finalised till the end of next year. But as a part of reviewing our IWCM strategy, we will be re-looking at the option to reintroduce something like the smart water rebate program. So part of that will be, I guess, building the case for the reintroduction of a program. So if we can show that by paying some users or all users a certain amount to install a rainwater tank, if we can show that that provides benefit, then it has a better chance of getting up and ending in the strategy. So it'd be good to talk to Steve outside of this and get some input on that, because it was a great program and it did help to reduce the overall demands on our drinking water system. So that was it, just a comment really.
It's a shame such a great program had to come to an end, and again, it does get back to money, Tracy. That's what it's all about. But I think everyone in the council position and looking at the future understands that yes, there are going to be some big outlays in the beginning if you can provide the business case for why you're doing it. And I think that's where we're at with water. I think we've been through that hump with energy, because you don't, it's quite compelling, the arguments for putting on solar cells and grid converters and these sorts of things. With the knowledge, knowing that down the track you're not going to be paying energy bills at all, that's what it all adds up to. And then the house with the solar cells on it is in fact a decentralized part of the larger energy grid. So this is what we are trying to do with water, but water is not like energy. They travel on different conduits and we use them for different things. But and the water is one that comes and goes too. It has no domain. You can't harness it as well as we can with energy. But it's look, if you can get because what happened, I mean, with look, I don't want to sound like I'm putting the knife in the Hunter water, but when you're a state-owned water entity, which MidCoast isn't, you seem to be guided a lot by the money from the state revenue and these sorts of things. Now, once BASICs came in, I remember talking to the Hunterwater GM one day, and he said, look, it's not really their problem, because he says now, just as time goes on and there's natural renewal of dwellings, they'll have to abide by basics. So why should we be giving a subsidy when they've got to put the tank in anyway? And look, I can see the business sense in that, but if you really want to put the rocket up someone and get it done quicker, you keep the rebate in for retrofitting where suitable. And I think a lot of that can slip into, say, when someone wants to put on an extension to their house, put on the Queensland room or something like that. It gives council, because they'll have to put in a DA to do something like that. That's the opportunity where you could be offering a rebate, where they're adding roof area, but they're not adding use, if that makes any sense. So you want to be able to, whoever builds any sort of harvestable roof area, we should be able to tap into it some way, point or form. And like even with the solar cells, a friend of mine in that industry, he talks to councils about putting, community-owned solar cells on top of public-owned buildings. And it's still just trying to get across the line because of all that fine print and, about who owns what, whose responsibility, and it's on our building, it's all that, well, I won't call it red tape. It's just the I's you've got to dot and the T's you've got to cross to make it work in a legislative regulatory world. And I'm happy to engage in that sort of conversation as well, because as long as it works, it will work very well. And as I said, these circular economies is what I'm very big on. Again, it depends on data, and it's not about privacy data or anything like that. We're just talking about general water use data. I mean, I don't have to know how many people live in the house and what their job is or how old they are. It's really, hang on, we've got a community here, and we're using water, and this is how it's distributed. Well, we've got these buildings and someone else is going to build a warehouse, and well, why not, let's marry them all together. Here's what our water availability. And once you've ascertained that, then suddenly it turns into water security. And that water security in a community, and when you've got lots of communities in a bigger catchment, well, again, it's just the, it becomes your new management unit rather than looking at a catchment-wide scale. Now, to me, it's pretty exciting, and it's great to have so many people on board that are, are already in the game, really, and moving forward with it.
Okay. So moving forward, so if you individually like to sort of do a case around and do a mapping around what's the best strategy, and would like to get in touch with Professor Stephen, please do that. I'm going to send the recording of this video to everybody, and I'll include Professor Stephen's contact there in the email. So if you're interested in taking up that conversation for individual part separately with Professor Stephen, please do that. And if it comes to the to a question of having some common understanding, we're happy to support there, and again brings Professor Stephen along into the core team, into a group where we come together. We'll talk a bit about the core team in a bit, but it's a space where everybody comes together, especially the caravan park owners and managers and the council, and so it's a co-design space. So any input that you need as a common understanding, something that we can do together, again, we'll bring back Professor Stephen to do that. So before we move on to the call to action, anything anybody wants to add? Professor Stephen, Tracy, anybody?
Yeah, I was just going to say, in the aim of keeping things moving and keeping everyone engaged, it's say for example, we go to a site or we get some detailed data. We'll just for argument's sake, we use the amenity block at Ocean Shores, where we've got the data. We've got 3 months worth of data. I can have a look at it, and then we can come back and have a little half-hour Zoom presentation to say, well, look, this is what we've found here. Look, this is incredible, or this is really weird, or is this happening over at your place? you can start having those sorts of conversations, and then you find yourself just talking water with your neighbours, and that's the way it should be, really, because a lot of our water management, it's a much, well, I line it with, you talk to some young child and, where does milk come from? And they say, aisle 7 at Woolies. Well, we all appreciate that disconnection and don't want it to occur. Well, a similar thing's happened with water. Not many people, we don't, if someone says, if you ask someone how much water do they use each day, they don't know. And I'll say, well, what did you do today? Oh, I had a shower, I used a dishwasher, I did it. It suddenly becomes a function of what they actually did on the day rather than being just a generic number of water floating through the house. So then you can start talking behavioural practices as well. And that's a very good way of which, most water authorities have done that very well, because you've got your reduced reduced flow shower heads and half flush toilets, and they've been around for a long time now. But they only have a very minimal impact on the bigger system we're talking about. But they have a greater impact when you incorporate rainwater harvesting, and then if you're in an area where you incorporate wastewater recycling and a whole heap of things. But then from a business perspective, if your wastewater treatment plant and recycled water being sold to clients is owned by, say, a Veolia, and something else is owned by MidCoast Water, you don't want to create a water market, a water cartel or a water competition, because the water's always there. This is the thing. I mean, we shouldn't have to pay for water, really. I mean, if you had a good rainwater harvesting system and you managed your own and you understood your behaviour, you understood your uses, you probably wouldn't need a mains water system. But if you want to live off grid with a whole people in that same area and you don't have a mains water system, and there's no one in the hinterland growing your food, there's no one, there's a whole connection of why we need water. There's you can't have industry, you can't have a whole heap of things. So you can't run industry through a rainwater harvesting tank. You do need all these different components. And for 100 years, we've just been using the one centralised paradigm, which has, in my mind, destroyed our rivers. It's done damage, particularly out west. The point where the groundwater is running out in the Murray-Darling Basin. We've got, there's no rainwater harvesting that's going to save them out there in the face of declining rain. It needs to be a change in practice and a change in the way we do things. And on the east coast of Australia, as I said, we're blessed to have the rain. Things are changing. They will continue to change. But if you strap in and arm yourself upright, you're going to have a pretty, better chance of going through it than someone who's, just going to be relying on the dams and desal plants and other things that just generate quite a lot of revenue for those involved.
All right. All right. So before we move on, anything to add, Tracy, or should we?
No, I've got nothing else to add.
Thank you, Andrew. So let's move on to the call to action.
Thank you, Nirmal. I think everybody here has already shown an interest in getting on to the co-panel between MidCoast Council and ourselves.
Murray was not in the conversation, so
Murray wasn't.
It'll be good to give him a
So what we're looking at doing is basically going on a journey together between, at the moment, mainly the park operators, MidCoast Council /water, in building a resilience plan for our region to secure our water in a usable and sustainable way for the future. Water is pretty much our livelihood, and we need to be able to look after it. In mind with frequent events, we've just been through the droughts, the floods as well. I mean, floods have a big impact on our water supply, how much we're not able to draw out of the Manning River after a major flood event. I'm not sure what the figures are and how many days, but I know it does have an impact. So for us to all to get in and generate a new system that we're all happy with, and the more of us who can put our time and effort, thoughts into it, the better the plan will be for ourselves. MidCoast Council, I'm sure, could just put a blanket plan in and say, this is what we want you to do. That's not what they want to do. They want us to get on board with them and help them develop a plan that will suit us. So basically, I think it's a worthwhile cause. Time-wise, it's not going to take up a lot of our time. It really won't. There may be a few hours here and there, and it won't go on forever. Once the plan's developed, there might be a bit of tweaking and a little bit of comeback here and there, but it's not a major thing. So I would encourage everybody to talk to other people that they know in our industry and get them on board with us as well. Get them to join in, get them to come and help out.
Thanks, Andrew. All right, so let's bring this to a close. Special thanks to John, who let us use his sitemap and his data to do a case study and to be used in the workshop. Thanks, John. And Professor Stephen, thank you so much for your amazing input. I'm sure we are going out of this room with a bit of change perspective around how we can make use of that valuable resource. Thank you.